I'd like to welcome everybody to the second video in this Dynakit ST70 restoration series. If you haven't watched the last video, click the link right up here. We'll take you to that. If you haven't subscribed, hit the subscribe button and that bell right now. In the last episode, we started with an introduction of this amplifier as it was originally restored in the ST70 resurrection video several years ago. We did an unboxing of the parts, and then we started to mark, annotate, and strip down the transformers off of the chassis. These transformers then had their shells removed so they could be taken down to Jason's to be sandblasted and stripped. They were prepped and painted. Custom bolts made out of threaded rod and egg-core nuts were fabricated. They were reassembled after the transformers themselves were also painted to improve their appearance. And that's where we left off on the last video. This brings us to part 2, where we will now be doing the assembly of all of the small components on the chassis and things that the power transformer is going to have to connect to, because this is going to be our first primary component right here. So that's what we're going to be doing in this video. Hopefully by the end of this video, we're going to have a situation where we're going to be able to plug this in, probably with a lower voltage because we're not going to have any load on it, and be able to test all the connections coming off the power transformer. So let's get started. First thing I want to do before I begin this project is point out, especially in this particular phase of the project, these particular screws and nuts, the replacement ones that I got, they all have the lock washer built in, the star one that bites into the metal. These are going to be a 1/4-inch socket for the nut, and for the screw, it's obviously a flathead. This is a size 4. So that's a good fit right there. I'm using a sized one, not one of the graduated ones that's going to mar the finish. Remember, these are exposed. You don't want to mess them up with some one-size-fits-all screwdriver. Right here on this area where the output transformer sits, on the underside is where the choke is going to be. So the choke is going to have to be done on this side first. Over here are some screw holes provisioned for a long phenolic board where the capacitors and some other components sit for the filtering for the power supply. So these are prerequisites that'll need to be done. We're going to open this chassis up. I'm going to put a towel down to protect the chassis as I work on it. But what I would like to do beforehand, not go too much off on a tangent, but I'm going to pull the old choke out. I want to compare the old choke to the new choke. And here we see, for reference, in this location, as I lift up the chassis, you can see here's the choke. There are 2 screws that hold it into position over here. I'm just going to remove this now. Put this old chassis back off to the side. So I'll cut back a small length of cable for testing. Now we will hook this up to the Genrad impedance bridge. We will take measurements off of this and compare it to the new one. See, the transformer is hooked up top or set for resistance DC. Looking at the ×10, everything is perfectly balanced on the beam here. And we're seeing, you can see just right here, comes right in the middle. It's 63 ohms. So that's what we're gonna go with and write it down, and we'll see what we get on the next value. An interesting amount of trouble tuning this one. It came out to a 1.5 Henrys with a higher than expected Q of, we're looking at what, 9 on the scale here. So you can see how twitchy it is. That's where the dip is. The sensitivity is all the way up, so just moving a little would have the needle off the screen. Yeah, so that's, I'm going to write that down. That's going to be 1.5. I didn't even realize the paper I'm writing it down on that was folded shows the values of the new one. It turns out I was off by 1 ohm on my old one and off by just a fraction of a Henry. That's pretty good for the old one. There's no way this thing's going to tune to 1.75. No way at all. So we'll see what the new one is, how far off it is on this. But yeah, wow, how about that? So I got the new one propped up on there. I'm going to start these tests all over again. So I'm seeing 64 ohms on the new one. That's just fine. Now we'll test inductance. This one actually came in at 1.3 and a half, 1.35. Not that it really makes a difference, but yeah, they're all close enough, so that's good enough for me. Having done more testing than any choke ever deserves, I am now going to install this choke as the first thing to be installed in the new chassis. I will put those chassis screws right back in, not all the way, just so I don't get lost. Be situating the choke right here where it will be connected to the capacitor over here. So I'll just lay that over there, take out the selected screws. And the goal of this is to install it without scratching anything. Hence the towel and all of the safety things. Lean it towards the back like this. Get the screws in. And situate a nut on there. Try to get a couple turns on it so it doesn't fall out. There we go. Now that it's secured, drop the other one on, no worries. And this is how scary it's going to be for every single part because it's polished stainless. For these larger ones, for securing, you should be using an 11/32 on the nut, unless you can't find your bit, and I guess you could get away with a 9mm on the inside. Also, I have a larger screwdriver bit that I use that is sized for these particular screws. And the standard procedure, lock it down on one side and tighten it on the other. With everything tightened down, the first piece is officially installed in the amp. Next, we install the power and mono stereo switches. Mono stereo is the 3-prong and the power is the 2-prong. The 2 prongs point towards on. We can see this switch has a red dash indicating on. So on will point down as the amp is upside down. So just like that, it's on, like that. The old switches were threaded, requiring no nut. It was just the screw. These are not threaded. So we have the nut for each of these that could be put on the back. I go out of my way to retighten the lock nuts in the back so that the front screws are fully tightened at exactly 180 degrees in line with the switch. These screws will be done in the same way, so everything is uniform. So that is the on-off switch. I'll conduct the exact same procedure now with the mono stereo switch right here. And there we go. The next switch is now installed. While I'm here up front, I'll assemble the gold-plated input jack board, and then I'll install it up front as well. So right is red, and we'll just have to unscrew this. Interesting though, there's 2 of them. Wonder if you would use both. I think I would only use one. I'd get away from the whole gold-plated thing though, wouldn't it? I'm going to hand assemble both for now so I don't lose the pieces. I'm not going to torque it like crazy. And should I decide during the build that I'm just going to remove the gold one, at least I'll know where to find it. It'll be right here. It's obviously a good reason why you included it in the package. It's probably so it bites down better than the gold portion. I'm going to actually put this through the phenolic material first. We're going to switch back to the old chassis to remove a couple more items. We're going to be removing the rectifier, which is under this screw, as well as the fuse and power cable. So let's do that now. I should probably remove this board too with the capacitors and resistors while I'm here. I don't know if this was standard back then or the person who built this had no creativity, but every single wire is black. It's not a major problem, but I just wanted to point that out. We're going to be going off the schematic to put this back together. I'm going to remove this connection here, this piece of material that holds everything. I'm also going to remove the rectifier with it, just all in one shot. I'm noticing here as I look at the rectifier that there is a screw and nut that goes all the way through it. And I'm wondering if that screw came in the set. Looking at the size of it, it may mean a trip to Lowe's. So I'm not sure. We're going to take it out. We're going to see what we get. Definitely believe that this size screw is not in the kit. So it's either Lowe's or a custom one that I'm going to have to fabricate. Definitely don't see myself putting this in a new amp. So anyway, continuing on, I'll snip this connection here to ground. I'll snip this connection here to the bias pot. Then I'll snip this other connection to the bias pot over here. Now this board should be fully detached. I can remove it as one piece. And it's just held by 2 screws up front. It was concealed by the transformer. There we go. Again, we're done with this chassis for a little while. Next, we're going to be dropping in these bias pots. It has a large nut up top with an interference fit that sets the height of it. That's going to protrude outside the case. We can see it stops just about there, and that's going to be basically where it stops outside the case. And then this bottom nut is going to come up, and that's going to hold it in position. The direction of these connections is to face forward towards the circuit board. I flipped around the lock washer to be on the top side, so I can put this through like this. And this nut is not the same on top and bottom. It only goes one way. I could get this on here nice and tight like that. And then from the bottom, I could tighten that nut up. The size of this nut is 1/2 inch. And the potentiometer needs to be held in place so it doesn't shift while tightening. Stop now and again and re-inspect. And we have to let it shift a little bit. There you go, there's the first one installed. I do the second one now in the same fashion. Both are perfectly symmetrical, aligned with the chassis and free spinning. We're going to call that finished. We're going to begin with the assembly of the rear jack. Turn the chassis around for reference. I'm going to set up this board here, figure out where things are going. And it looks like the first hole is going to be the common. So I'm going to just get that one set up now. I'm going off this diagram right here. And these boards are mounted on the outside of the chassis. Just sort of figuring this out right off the diagram. I believe I got it. According to those 2 brass washers. I believe that's one of them. I still have to tighten this down, but you need to open it up, and there you go. You have a place to stick the cable in, or obviously if you're using banana plugs, you can stick it right in the back there. Much better than the screw down method. I just got to get this tightened up. I found it doesn't clear the back with the extra plastic piece. I simply removed them. Haven't tightened these down yet, but I'm going to do another fit. Make sure they're good. They look good. Just place them in here right quick. Yeah, that'll be fine. There we have it. First one done. Nice and symmetrical too. That'll go nicely. Both are done. Let's throw them in. The purpose of these two is, and this is isolation. This is not tied to ground. As you can see, the unused lead, which is the 16 ohms, will be in the future soldered to this. Over here, this will be tied to one of the bolts on the chassis, and that'll stop it from floating in the chassis. It's just a safety mechanism. First one's completed. Screw heads are lined up. Now both of them are in. That completes that task. I forgot that I needed to remove the outer screws of each one to add this insert. I'm going to do that now right quick. So I've added those pieces to the screws here. I've slightly cambered them up to get them off the bottom and off the wall at the same time, give a little bit more clearance, so just a couple degrees. They're both evenly spaced upward a little bit. So now that completes these output jacks. I'm going to drop in the fuse right quick. That was one of the easier steps of the project. So I'm back from Lowe's on other business. I got a hold of a 6/32 screw. I got a longer one and an Eggcorn nut right here. And what I did was I checked out the hole that was in the chassis, and it does clear the chassis. I also checked out the rectifier. And the thing is, the reason why I got the Eggcorn nut and the long screw is the only thing they have available is slotted and I thought it would look kind of strange having that in there, that being the only one. So what I'm going to do is I'm going to snip off the top of this and use this as a size threaded rod to replace this, and then I'm just going to make it a little bit longer, drop this on top, flip it upside down, and then that's going to replace it, and this will match all of the other Acorn nuts that are sitting currently on top of the transformers. I'm going to drop this board in with the capacitors, and note that the wires will be replaced, just not right now. I have a special project in mind for these wires. But as for now, I just want to put this in right quick and bring our rectifier into position so I could size up some of the hardware. Just brought a bunch of hardware with me. Okay, that's installed. And while they cannot be seen, the screws are lined up, just like these, because I know that they're there. The first portion of this rectifier will just be this screw that was fabricated lock washer and a nut, and this will leave a stud sticking out through the chassis. I'm going to have to tighten down this stud so that the Acorn nut is parallel, just like these two nuts right here. Everything's lined up real nice. So now we'll set the rectifier on, drop on a washer, then the rectifier, and the washer, then a lock washer. It comes out just perfect. Then the nut. There we go, rectifier is perfectly situated in place. This is done. Mounting's good, nice and tight. Everything's set up exactly as it should be. It's even further off the chassis than original. That's nice too. So yeah, very cool. For those wondering why I'm still using the original selenium rectifier, I've never had a problem with them. I know that people will tell me that I can't use selenium because there's all sorts of problems with them, because they read somewhere that somebody said that there were all sorts of problems with them, because that person read somewhere that somebody said there were all sorts of problems with them, yet nobody's actually had any problems with them. They just heard somewhere that when they fail, they smell like garlic, right? But I have a lot of pieces of equipment that have original selenium rectifiers, don't have any problems. So in case you're wondering why, don't bother commenting and asking me why. Got tons of equipment, still uses them, don't have no problems. And that's all there is to it. Case closed. It's time for tube sockets. And this is going to start off with the rectifier. The rectifier is going to be the only one to point inward on pin 1, pin 8, right? So a little notch right there. And the rectifier is going to go right here. We hit from under the cabinet. All of the screws, of course, going to be lined up. Let's do that. That should be a nice fit. It's going to look good. So it looks like in order to get these tube sockets right, they're going to need to be shimmed. Not too bad. I'm going to have to put some paper in here, because if you just screw them in, they're going to be offset, right? You see that? Cardboard is too thick. We're going to have to try some, perhaps paper, just regular paper. Seems like a single ply of paper does the job. So the single ply paper seems to shim it nice in the center. So I'm going to try and tighten it down while the shim is in without disrupting it. Just tight enough to stop it from moving. That should do it. We can see that with the paper shims, it brings it really nice to the center. Now I could get the screws lined up. There's one socket done, 4 more to go. Actually went with a different way, a piece of paper that actually rolls up twice to get an even better centering than before. So I'm going to revisit the rectifier after I finish this socket. I'm also going to leave the paper in until I'm done with the tightening procedure. This one's completed. I'll now remove the shim. We'll have a look. Perfectly centered. Screws are lined up. That's what we're going for. Perfect. And that is the end of tube sockets. We're going to be moving to preparations for the installation of the power transformer. I have the supplied rubber dampeners that were added to this that are going to change the length of the threaded rod. In a previous video, we saw that I installed this threaded rod a little bit longer for the dampeners. We don't know yet if I have to shorten that threaded rod. We're not going to know till I install it. We're going to find out. What I'm going to do is I'm going to replace these nuts with locking nuts I'm going to tighten this down. I'm going to put the rubber dampeners in between, and then we're going to place it in. We'll get a feeling about how long it's going to extend on the bottom of the chassis, if it's going to be burdensome or not, and we'll decide if we're going to let it go. That was nerve-wracking. It's in. I'm going to be temporarily running up a couple of nuts on the bottom here just to support the transformer. I don't want it flying out. So this is just for safety right now. Put one near the back corner. Now it's really starting to look like an amplifier. That's nice. You see the shadows from the pots cast over here. Okay, now we can finally flip it over and have it on an angle. See what we're working with. And now it also has some bulk, so it doesn't fly around everywhere. It's got some weight to it. That angle is so much nicer to work on. Have to make sure you keep the towel under it though when you do that. I got my coil, got all my connections from the power transformer now. We can now finish mounting properly the connections here. Some of them, of course, will have some clamps, but those clamps are not going to be introduced until after the cables are soldered in. That's why I have the temporary connections. I'm going to be moving the temporary connections as required. And we still do have, believe it or not, another thing to mount right here in the chassis. This is our star ground. We'll be going here. So we're going to do that next. I put the permanent lock style on the back. I got the temporaries on the front, and so it will remain until all the wiring is done. I'm going to start wiring in the power transformer. I'll be starting with the filament voltages here on 2 and 7 of the EL34s. I'm going to be using the bottom holes for these so that I could later wire in the pigtails that'll move onward to the other sockets and off to other locations. First connection's in. Next will be this side, the green. Next I have these two connections that went to the double 20 microfarad capacitor. I'll do those now. I have to clean up the existing connections first. Cleaned up, dressed up, ready for installation. I'm going to start wiring up the rectifier on this side. Pins 4 and 6 will connect to this cable here, and just like that. Other side of the rectifier will be on 2 and 8. In case you're wondering what I do with the screwdriver, this is flux that I apply to the wire and the connector before I solder. Now the connections to the rectifier are done. I'm going to add the black power cables now. This side will go to the fuse here, and the other one will go to one side of the power switch. Those connections are now completed. Next I will be doing the connection to the rectifier right here. So I got this cable soldered to the rectifier. There's not a whole lot of room to work. Now that it's soldered, I'll screw the rectifier back down. There's really no margin here. For the last connection, we are going back to the old chassis. And what I need to do is remove this small star ground tab from the chassis. There we go. Now we're going to reinstall that ground in the chassis. I've cleaned up the grounds and I'm installing them now. This one presents a minor challenge because it has to be dressed both in the front and the back. So I'm putting them in loosely now, and then I'm going to have to match the front screws while maintaining the integrity of the back. I actually ended up readjusting this to canter a bit to the right to provide some strain relief to the transformer since this wire was just too short. I've added that final connection, which is the ground cable right here behind this pot, but I've not soldered it, so I could add the last connection here for the power transformer, which is the power cable. I will do that now. I'm indifferent to grounding the chassis for stuff that came without grounds. I personally don't care, but this might be used outside of my house or my lab, so I'm going to add a 3-prong power connector and ground this off to that star ground that I just installed. So now I'll wire the power cable into the switch, the fuse, and the ground. In installing the power cable here, I've constructed a strain relief with 2 cable ties connected to each other. One of them wraps around this bolt that comes up here. The other one wraps around this cable here, and then the bolt came in over here around that cable tie and secured everything together, and it provides genuine strain relief in both directions, right? So that came out really nice. Because I can't put a whole lot of stress on it, I may put a little blue Loctite here, secure that, and call it a day. The green wire will come down and meet this star ground right here. The black wire, the hot wire, will come to the fuse. Now on the fuse, I flipped it around so it is now sitting correctly. I have added an extension to the original black cable. This extension comes up here. I have moved the transformer side up to here and now in the correct position, so that the hot wire is now on the center pin so that you do not get electrocuted and kill yourself when you try and change out a fuse. This is the correct position. This one will be connected now to here. The white wire will wrap around and connect to the switch. With that, this stage of wiring is now completed. Power testing will begin. In the first test, I have the voltmeter hooked up to the heater of this particular side, and what I'm going to do is I've already brought up the variac to 1/3 of the AC line voltage, so it's about 40 volts. I should expect to see 2 volts on the output here, correcting for the no load. So I'm going to turn on the variac. I have the switch to the amplifier on, and we could see about 2.1 volts coming through, so that's very good, and that's going to be third power. So I'm going to check the power switch now, make sure that's operable. There's off. And there's back on, so that's working very nicely. So now I'm going to move this over to the other side and check the brown side. Connected to the brown side, fire back up. Brown side also shows the exact same reading, 2.1 volts, and that tells me at that ratio, both of them putting out the same heater voltage, perfectly fine, and move on to the next test. I'm now connected to the 5-volt rectifier heater, but we're looking at 1/3 of that, so somewhere between 1.5, 1.7 volts, I don't know. Yep, and we're seeing 1.6 and change. So that looks good. We're going to move on to the next one. I can't imagine what this side is going to be with absolutely no load, but I am at 1/3 voltage, so I'm going to expect a couple hundred volts or something on this meter. I have it on the 500 volt scale right now, so we'll see what it is. And I'm seeing 250 something. And that tells me that winding is probably looking good. So I'm going to move on to the next. Rectifier showing about 17 volts at 1/3 of the voltage output on the AC side. That seems about okay for this test. These being the center taps to these respective heaters. I didn't measure these by voltage. What I did was, the one on the right being green, I would measure the resistance from this to each one of these and expect the same amount of resistance. Likewise, I did the other one for the brown, and they were the same for each one for both, and that told me that the center taps were good, and this test was completed. And with that, our burn-in test is completed, and this phase of our amplifier restoration is also completed. So I'm going to end this video here. If you enjoyed this video, click that like button. It helps me a lot. When the next video comes out, I will post a link here for you to click on. I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?